Welcome everybody to this first of two training sessions today. This first one is about persistent identification of instruments, and then after the coffee break we will have a session on GDPR from a policy perspective. So Ines, would you mind showing the housekeeping rules and start
yes.
the recording? Or we are recording already, yes.
I will do that. So I think Markus has to stop the sharing of the screen so I can show the code of conduct. Thank you. So I think most of you should know the code of conduct by now, but I want to repeat it just briefly. So I would like you to use your real name. You can change that in the participant list because it will help in the discussion. Your microphone should be muted. It is by default, I guess, when you are entering. So please just unmute it when it is time for you to speak. Use raise hand if you want to say something. You can see that when you open the participant list there, you can use reactions and of course raise the hand, and you need to put it down yourself. So you lower the hand after you are finished. And please state your name when you start to speak, because with rising numbers of participants, you can easily lose the knowing of who is talking when. And you can either vote yes or no when there is a question, also next to the raise hand function. And you can use the chat if you want to ask anything, and we will see that too. That's it.
Thank you very much, Ines, for reminding us about that. Okay, so let's start then. So what we will be doing in this first session is that Markus Stocker, who has been one of the co-chairs of the RDA working group on persistent identifiers for instruments, is of course also one of our own in the ENVRI community. He will be introducing the topic and then also make a extended discussion about the metadata models that have been proposed for instruments and the persistent identifiers for instruments. And then we will launch into an experimental session with 4 breakout rooms where you will be working with a hands-on exercise, trying out the EUDAT experimental instance of what they call a B2INST service. And then we will reconvene briefly at the end at around 10:45 to share experiences and have a Q&A session. So with that, I'd like to hand it over to you, Markus, please.
Okay, thanks, Maggie, for the introduction. I think we can get started right away. So persistent identification of instruments, as Maggie said, this is a brief overview of what the RDA working group for persistent identification of instrument did, and I added a few additional notes. If you had by chance followed the Freya webinar that we have in November, some of this is redundant, so apologies if it's a bit duplicated, but I figured that many hadn't followed that, so I hope it's new material and as well as interesting for this community. First, a little bit of history. I think it's interesting for a number of reasons. To start with a little bit of history. So it started at PIDINST. That was edition 1 in Reykjavik in November 2016. And back then I was with Pangea and also in the TOR, Technical and Human Infrastructure for Open Research project. And that was all about, or a lot about persistent identifiers for data, in particular papers and people and so on. So I went to PIDINST suggesting, well, why don't we persistent identify instruments? There is also a DOI there for the slides if you're interested. And the spirit back then was a little bit, oh yay, we do yet another PID. Fun enough, there is also a website for that expression. Yeah, so I think it was simply to mention that instruments matter, and why don't we persistently identify instruments. Then there was the Freya proposal a little bit later, and within so Freya was the follow-up project for Tor, and within that we had put a little bit of effort also for this topic, in particular for Pangea. And just before Freya started, I then left Pangea and moved to TIB, and yeah, so that's why we grounded also a little bit this work in RDA, so that I could continue co-chairing. The interesting bit for this community is the next point. So we had then in March 2017 a Tor ENVRI Plus bootcamp in Helsinki, and this was about ORCID integrations in environmental research infrastructures. So it was another persistent identifier. But there I met Luis Darroch and Alessandro Gioni, and we were thinking about having this topic of persistent identification of instruments grounded in an RDA working group. That was the first ideas there at the Tor ENVRI Plus bootcamp. And then it all started in September 17. We had the first BOF at the Plenary 10 in Montreal. Then we had a case statement submission that's now RDA towards the end of the year. And then it started with the kickoff in March 2018 in Berlin, the 18 months of lifetime, and then a wrap-up session at P14 in Helsinki. In 2019. And then basically, last year, 2020, we sort of worked on the deliverables. We had a paper, I will speak a little bit of that, and also some other deliverables, which we published, polished, published, and then moved on to maintenance mode during that year, and also, of course, try to ensure adoption. So we were working with various instrument database providers or research infrastructures to try to look at adoption of the schema and also implementations that we have. Good. Little side note, what begins in Finland ends in Finland. If you paid attention, we had the Tor ENVRI Plus bootcamp in Helsinki, and that was the beginning. And the end was again at the plenary in Helsinki. Another note, I wish I could do a quick poll on this one about the logo. So PID, it seems pretty clear. I wonder if you noticed that the yellow ID is actually also a symbol for an instrument, and which instrument it perhaps is. It's a microscope. So we have creatively combined persistent identifiers with instruments. So why does it matter? I think this is clear in this round. Instruments play an essential role in creating research data, and also metadata about the instruments is important to determine whether the data can be reused in a different context, the quality, and so on. And I like to quote Borgman, who in a 2015 book, Big Data, Little Data, No Data, writes that to interpret a digital data set, much must be known about the hardware used to generate the data, whether sensor networks or laboratory machines. And she also goes on mentioning that in some groups, they had a problem that some researchers who operate or install instruments had long departed groups. And with that also the information about the settings, calibrations, and important information needed by the group later on. And they had to call these people back to get that information. So this is a good example for why it matters to capture metadata about instruments also. And of course, once you have that, you can do persistent linking of research data and instruments, but not just research data. You know, people calibrations, models, all kinds of things you can start linking to instruments. Instruments model, as you know, they are often mentioned in the literature. So you have perhaps an identifier for the model somewhere in the materials. But of course, it could be interesting to, in addition to the model, also mention the concrete instrument instance that was used. And of course, there are other use cases. You can imagine using this also for inventory, but also funders could be interested in having information about or persistent identified instruments, because yeah, you need to fund, and some instruments are very expensive. And knowing also tracking the links between the research data that instruments generate is of course interesting also from a funding perspective, because you can decide which instrument to fund, or which instrument might need a second instance in the institute because they are so much used and so on. Good. What the working group did is, in a nutshell, the following. So we collected use cases. So it was a use case driven metadata harmonization exercise. We identified the common metadata. And this is to remember about instrument instances. So each use case had given a table for the metadata that they'd like to see, that they need. And we looked at this metadata from these use cases and what are the common elements, what are the frequently mentioned elements or attributes. And we harmonized a little bit the language there and so on to come up with a sensible common denominator. And then we developed this common schema and we published it. Then we had some community feedback on the schema, and we integrated that as well. So there were a few additional versions during the lifetime, and of course this work is ongoing. Another thing that we did is to try to catalyze the schema implementation in existing PID infrastructure. So what we didn't want to do is to set up another PID infrastructure, some like similarly to what IGSN, for instance, did, because we didn't have, of course, the resources and no plan for sustainability of it all. So what we did is instead say, okay, there are a lot of PID infrastructures already out there. Why don't we leverage them and just within the scope of the working group, develop a schema, suggest that schema for instruments, and then work with existing PID infrastructure so that they can perhaps implement it. And I have a few examples for how that works. Then we also prototype the adoption with existing institutional instrument providers, and I have a few examples of this as well. And we engage with the wider community, of course, at RDA plenaries and hold regular meetings. So a few notes on the use cases, metadata analysis and schema. So we had 15 use cases that we collected between November 2017 and February 2019. 60% were in earth science. That has probably to do also with the background of many of the most active members, and also the co-chairs actually were a little bit biased towards the earth sciences, which is a little bit problematic, but yeah, we hope that with future adoption, we can get also input from life sciences, astronomy, and so on. We had some of that, but with 60%, clearly there is a little bit of earth science weight here. 14 of these 15 were complete. One of the use cases never submitted the metadata table, so that was not considered, and also 10 of them were timely. So not all the as you can see for October 2018 timely. So we had also submissions until February 2019. Because there was sort of the cutoff date where we started to do the metadata analysis in October 2019. So 10 were effectively used for this analysis, and then the rest was then used for a sort of a validation. Then thanks to this metadata analysis, we had a first version of the schema, which is available in all versions on GitHub at this URL. And we then also revised the schema, including some community feedback. It wasn't much, but there were some points and some changes due to newer ideas after that. A few notes on the schema essentials. I would say I have the second part here today. I will speak a little bit more about the fields. So we have, of course, things like owner and manufacturer. We have a possibility of capturing the model. Measured variables was something very interesting. Many have pointed out it would be great to have also the variable measured, metadata about them. Dates, what is important, dates for the instrument like commissioning and so on. And the mechanism that also DataCite has, and perhaps others, with related identifiers and alternate identifiers, which I will talk a little bit more also later. Schema implementations, we have a few implementations of the schema. So these are existing PID infrastructures. And as I mentioned, during the lifetime of the group, we had two. That's DataCite and EPIC, and they are probably quite known in this round. So DataCite has implemented, or let's say, what we did for DataCite is an alignment of the PIDINST schema with the DataCite schema, a mapping. So of course they didn't implement directly and fully the PIDINST schema. They have their own schema. So the only thing that we could do is this kind of mapping for the time being. They are thinking about adding now and extending also the DataCite schema to accommodate some features of the PIDINST schema. So here we have only a partial mapping. There are, for instance, no measured variables. There's no such thing in the DataCite schema. And also a model name, for instance, cannot be included. And in addition to that, you need to a little bit bend the terminology. So we have we use creator, for instance, for the manufacturer, and also publisher, publication year, and so on. They don't make much sense. Some of them are optional, so it doesn't matter much. But still, if you use this DataCite schema for instruments, it's not entirely, of course, designed for it. The sure advantage is that DataCite is a globally known PID infrastructure. Many have a membership, they have good infrastructure and good services and so on that people already know and use in the workflows. So that's a big advantage. The second is EPIC. EPIC is a full PID schema implementation. They can do this in their infrastructure in contrast to DataCite. It's not in sync with the most recent schema changes. We had a few changes in the schema that they haven't adopted yet, but otherwise it's a full schema implementation. EPIC is perhaps a little less well known and perhaps a little more a European-centric PID provider. So outside Europe, this might pop up to a question mark. People don't know it, so compared to DataCite anyway. So that's perhaps a slight disadvantage. Then I'm adding EUDAT also on these slides now, because that's sort of the new kid on the block here. They've developed a B2Inst service for registration and cataloging of instruments. I think that's interesting. We're going to use this also today, so that you can familiarize with B2Inst. And I think it's particularly interesting for those institutions and research infrastructures that don't have a DataCite or EPIC membership. As you know, you need to be a member to register DOIs with these infrastructures. So if you don't have a membership, then B2Inst could be quite an interesting alternative. It's currently still a prototype. It's not a productive infrastructure and service, so you need to be careful about that. But to test it, it's certainly interesting to try it out and also to provide feedback from this community to B2Inst, and therefore EUDAT. That's what they are also looking for. And this is a result of a recent DataCite Epic and UDAT collaboration, which started after Helsinki, the Helsinki plenary. People there met and yeah, thought that why don't we discuss this and develop a new service, a B2 service. There is more about this later in this training. There are first documented tests that we did also during the lifetime of the project or the working group. So they were at Helmholtz-Zentrum Berlin. You can see here a number of links here. So and DOIs also, persistent identifiers. So Helmholtz has used the DataCite approach. We'll have a little bit more about this. And I have also some screenshots to show how this looks like. And then we have the BODC, the British Oceanographic Data Center. They tested the EPIC implementation. And also here, you can see there are some DOIs for that identify their instruments. And I have some screenshots about this as well. So the DataCite approach with an instrument from Helmholtz-Zentrum Berlin here. Yeah, you can look up the, as you would expect, the DOI in the DataCite search. So you get the metadata, and of course it resolves then on the landing page here on the right at Helmholtz-Zentrum Berlin with more information about the instrument. An interesting point that I would like to make is also that DataCite has worked within the Freya proposal on additional services. That's on one end the DataCite Commons, and this links their identifiers, DOI identifiers, to other identifiers, in particular other works, so papers, but also people, organizations. And of course, if you use DOIs for instruments, you will also be able to look up this instrument in DataCite Commons, and therefore also have the links if they are provided in metadata to potentially papers that describe these instruments. There are some journals for this, where you can submit papers that describe instruments, or also organizations, of course, that are the owners of the instrument or the manufacturer and so on. So that's quite interesting, and therefore also you can look these things up in the PID graph, so a more machine-readable interface here to look up these identifiers, and also interestingly, of course, the relationships between these identifiers. So you have here things like raw identifiers to organizations, here the Helmholtz-Zentrum Berlin, or here, for instance, a paper that describes this instrument. That's the Journal of Large-Scale Research Facilities. And you can capture these links, of course, in the metadata of the instrument. The EPIC approach is slightly different. So this is what BODC has prototyped. So this is a full implementation of the schema, and they do it like this, that sort of the data can be encoded in JSON. Here you can see in the attribute directly. So it's a little bit maybe cruder than what you have with the services at DataCite, which are more advanced, I would say. But the advantage is that you can implement the full schema. So as you can see, you also can capture here measured variables. And BODC does this, of course, with the NERC vocabulary service. The values here are actually identified resources for the variables. So you can look these up and also get more information about the variables. Few words on the deliverables. We had a paper that you can look up. It's published with the DataCite journal, and has a lot more information about what I just said, a little bit more background. So that's an interesting read, I think, if you want to dig into this a little bit deeper. It's also an RDA supporting outputs, and you can find it online. In addition to this, we developed a read docs documentation for persistent identification of instruments, which is a little bit more technical. It goes also much more in depth in some aspects. It has some cookbooks for EPIC, and so step-by-step descriptions for what you need to do to use EPIC for persistent identification of instrument. We are also developing something similar for DataCite now. So this is a resource online. It's also an evolving resource. So as we get new use cases and adoption cases, we will describe these on this resource. Few words on adoption still. So we have a few institutions and infrastructures that have adopted this. I can mention also here ICOS. As you know, ICOS operates a number of instruments here, 150 instruments at various stations in various countries. And as you know, they measure in particular greenhouse gas concentrations, fluxes, some meteorological parameters, and do in general environmental monitoring in various domains. And of course, yeah, that's a nice test bed also for identification of instruments, and I'm working closely with Claudio here and Maggie also on trying this out. But they have, of course, a little bit of requirements also on their side. In particular, they're testing whether it works for them, but also they also rely on an operational service, and PIDINST and their implementations are perhaps not there yet. So this is all also in a TRL, I don't know, 5 or 6 stage, not 8 to 9. Also the implementation with DataCite and EPIC, these are, I would say, for testing purposes and exploration at this point. So if you rely on an operational service, also with B2Ins, you need to be careful with this. I don't think we are there yet. Pangea has also tested this with B2Ins because it's relevant, of course, also for data publications. They are looking forward to include persistent identifiers for instruments in their metadata about data sets, and therefore creating these links, curating these links, and sharing also these links then through existing metadata, the mechanisms that there already are for sharing these links. So that's links to Scholix also, even though Scholix look at data to data and data to publications, but you can extend this, and I think PID Graph did this, also this extension to other entities, including in the future potentially also instruments. And as I already mentioned, there is B2Inst also, which we will be using today at this URL. And just a brief description. So it's a collaboration between DataCite, EPIC, and DUDAT. DUDAT has developed B2Inst and adopted the schema, although it's not a one-to-one implementation. They have some additional fields and attributes that they generally have. For instance, size and format, which we don't, and geolocation, which we don't have in our schema, and they are also, like EPIC, not fully up to date with some of the recent changes, in particular about the possibility of capturing model identifiers and model identifier types. So don't be surprised if you see some differences between what PIDINST published in the schema online and also B2Inst. But here you can see a sort of a landing page, a name, a description, 2 PIDs, a PID and the DOI. Basic metadata following roughly the schema by the PIDINST working group. And you can also additionally add some files, additional resources. You can also cluster instrument in communities on B2Inst. And you have also some versioning possibilities. A few concluding remarks, because I'm slowly running out of time for this first part. RDA working group persistent identification of instrument has sort of created the first schema for the persistent identification of instruments. Obviously, something I would like to remember is that these are identification of instrument instances, not models. That's, I think, important to remember. And it's also, it has a focus on instruments used in research, although, of course, we don't strictly limit that, or there's no way to limit that. Not all instruments. In fact, we have some adopters also, like the sensor community, which are instruments that people also use at home to measure temperature and humidity in their environments. And this data is perhaps not directly used in research, maybe in citizen science project also, but it goes a little bit broader than just operational instruments in research. But also because it was grounded in the RDA, I think it had, of course, a focus on research and research data. So with DataCite, EPIC, and DUDAT, we also tried several implementation choices. So you have these implementation choices. You can look at them. You can see what fits best to your situation and infrastructure. There are first signs of schema adoption and also field testing. But I think we definitely need more of this, and therefore also this ENVRI training. Good, that was my last slide for this first block. Perhaps back to Maggie and also the question whether we should have some question at this point or we should move on direct.
So thank you very much, Marcus. In the chat, there's been a couple of questions. So one is related to what you just said there, that should one register PID for classes of instruments or instances? And that there have been some pros and or yays and nays to both of those approaches. And then there's also been a discussion on how you actually can add qualified references, for instance, to other measurements or to papers, etc. And you also touched on that a bit. I don't know if you want to say something about respond to those or now, or you want to show the metadata details?
Yeah, so I will do that also. So just briefly, it's indeed the instrument instances. That's the scope. We can link to models, and there have been some examples also how to do that. And that mechanism can be so we can leverage there the mechanism for models. We have a particular field model identifier now, and for related like papers or so, you can use the related identifier mechanism here to link to all kinds of things. Yeah, so perhaps we will see more about when we run through the schema in more details. This will perhaps be more clear also. I'm just trying to read the chat myself. Did you see anything else, Maggie, that we could address?
Well, there's also, I guess, a discussion about what happens when an instrument moves around. How do you update the record if there is, for instance, location also included in this registration metadata or not? Yeah, so this is, of course, a very difficult one. And we have discussed a lot about what is an instrument concretely. An instrument often has parts. So even though it looks like a one unit, one piece of physical object, it actually has a number of sensors and instruments attached to it. So it's sort of a platform. So all these issues were extensively discussed. And also the instrument can move, as you said, and can be also reorganized. So you can put them on a different vessel at some point in time, and so on. So this is all quite difficult to, I think, capture. We don't have geolocation. Maybe that's there is a reason for that.
because it's complicated. But one thing that I would like to say here also is that keep in mind that there is always this separation between the metadata that you sort of ship at the level of the PID infrastructure, so DataCite and so on, and the metadata that you can curate in addition within your own database and within your own research infrastructure. And these metadata can be, of course, on the landing page. You can present them on the landing page, and they can be, of course, different. And in particular, what you present on the landing page can be richer and much more tailored to the specific community also. And the community needs. So that's perhaps something to remember, that not everything that you can tell and you want to capture about an instrument needs to necessarily go at the PID infrastructure level. Of course, the disadvantage of this is that you then also cannot use this at the PID infrastructure level. In particular, you cannot search and filter for instruments that were used at a particular time in a particular location. At a global level, which would be perhaps nice, but currently something like this would not be enabled because of that. But you can enable it at the ENVRI cluster level, maybe, if we can get to a richer schema at the ENVRI cluster level, or of course within your own research infrastructure.
So I think we need to move on,
Yes.
but please keep your questions coming in the chat. We will save that and try to get back to you later on if you would like us to do that. So Marcus, your second part?
Yes, I will just share the screen again. Okay, so the second part, and I think you can see my slides for the second part, is about the PIDINST metadata, and I would like to give a little bit more insight about the metadata, so a few more details here, and also run through an example with B2INST, a concrete measurement system, and so that you can take a look at how this works. So first of all, the schema, this is a reminder about the URL. The schema is available at this URL in a readable format directly on the web. So if you have time to take a screenshot or something about this and you want to look at it live online while I'm doing this, you can do that. It's also useful in the exercise later with B2INST to keep that at hand because it has a few more descriptive information and so on. So it might be quite useful to have this URL on the side. Maybe someone can type it also in the chat. Good. So just briefly through the schema, we have adopted a presentation very similar to what you know from other schemas, in particular the DataCite schema. So those who are familiar with it should be quite clear how to read this. So in each row there is an attribute of the schema or an element of the schema. So we have an identifier. That is the actual string for the identifier, so 123/XYZ or something. We call this PIDINST because at that time we didn't have anything better, but currently maybe it should actually be the identifier type should be a controlled list of values. In particular, DOIs, handles, and B2INST I think also has handles. So we could specify this here, what type of identifier it is. There is a possibility to include a landing page. You know what that is, a URL. That's the page to which the identifier resolves to. In B2INST, that will be a B2INST UDAT site, but in EPIC handles and DataCite DOIs, that will be a page of your own, for instance, one that you serve from the research infrastructure to describe in further details and provide maybe also access to the data generated by the instrument in your research infrastructure. There's a possibility to include a name. And yeah, so something I didn't say is there is also information here about obligations. So it's mandatory, optional, and also occurrence, whether it's a 0, 1, or n. You can have the field in multiple times. So a name is the name by which the instrument instance is known. That's free text, free can write something here. The owner is also mandatory. There could be there must be one owner, but there could be multiple owners. These are institutions in a general sense responsible for the instrument and the management of the instrument. Could be a person, could be someone operating, it could be an institute providing access to the instrument. So that's a quite broad understanding of institution here. And about the owner, you can capture the owner name. That's a free text. The owner context, that's an email address, and an owner identifier. So that must be a global unique identifier. It's also an optional field. So if you don't have one, it's not a problem. But if you have an identifier for the owner, like a URL, would be great to include it here. Something similar for the manufacturer. So these are often different. Here, this is maybe the company who manufactured the instrument, or an institution who developed the instrument. Sometimes these instruments are created by the infrastructure themselves. And also here, you can capture a name, an identifier, and an identifier type. Also a similar pattern about the model. So as you know, of course, instrument instances follow a certain model, and about the model, we can capture the name and the identifier, and also here an identifier type. So this could be a URL or a DOI, and so on. Then a description. This is a free text technical description about the device and its capabilities. An instrument type. So in addition to the instance, the model, there is often some sort of classification of instruments, and that's what the instrument type is meant. So think about a thermometer, right? Is a good example. So you have various instances of thermometers, but you have also various models of thermometers, and you have also various types of thermometers. In addition, much more granular, so a taxonomy of thermometers. And this is what you could, in addition, capture here. I mentioned measured variables already, so this is an interesting possibility here to capture the measured variables also for other groups. It also links very nicely to what Barbara is doing and others in iAdopt, because we could link, of course, also persistent identified variables in this field, which would be the best practice, but it is free text because many communities don't have taxonomies for variables and these semantic resources for variable descriptions. Dates. Date is also a field that came up very often in the metadata submitted in the use cases. So this is dates that are generally relevant for the instrument. There is a control list of values that we have for the type. So I have here two examples, commission, decommission, but this can be extended with other types of dates that are important for the instrument. And then we have these two mechanisms which are already mentioned for the related identifier and the alternate identifiers. So related identifier, also here you can take the identifier itself. So that's a free text, but must be a global unique identifier. There is a type, so it could be another instrument, it could be a DOI, it could be a handle URI and URN. That's classical list of identifier types. And then an additional field here for relation type. Here you can describe a little bit more detail what kind of relation or how these two identifiers here are, so the identifier, but the instrument and the other identifier, for instance, another instrument, are related. And that's also control list of values here. So there is a possibility to describe parts or components of instrument through this relation type mechanism. New versions of an instrument. So you have two identifiers for instruments, and you know that one is a newer version of the previous one. Then this is the mechanism you can describe this, or metadata about the instrument, and so on. And something similarly in the sense of the mechanism, we have also alternate identifiers, but these are identifiers about the instrument. So in addition to the sort of the PIDINST instrument, you can also capture here like serial numbers, inventory numbers, and potentially also other alternate identifiers. So these are identifiers, sort of another alternate name of the instrument, as the instrument is also known or something. And this field here and mechanism is meant for that. Good. We can perhaps move on to an example. And as I mentioned, I would like to use the B2INST field or system here. Okay, I think you should see my my screen, hopefully, with the browser now. And I think Maggie is going to show a little bit more about how to use the system. So what I'm jumping directly to registering a new instrument. And you can classify this into a community. You can see that we have now in B2INST an ENVRI community. So Maggie managed to set this up in time for today, so that's great. And what I'm going to do is I'm going to describe a thermostat in my living room, or the thermostat in my living room. So I will give it a title, my thermostat, and you can create a draft instrument here. There is, and this now is not exactly the same schema here or template or form here, for doesn't quite reflect the fields that I just showed you in the previous slides, but perhaps close enough. There are some additional fields and some things are missing because it doesn't reflect the newest version. But I think for the exercise today, it's good. So as a description, I can provide a more technical description of the device. I could say, okay, my thermostat in my living room or something. The owner is now, well, not me, but the building construction company. That will be Gundlach. In my case, the context is an electronic email address. So here you have an email address. An identifier, well, they don't have a raw ID, I think, but we can also simply provide a URL, and the type here would then be URL, and the name of the owner is Gundlach GmbH. Now, Gundlach doesn't manufacture this thermostat. The manufacturer is Jira, so that's an identifier. Again, they don't have something like a raw or ISNI identifier. So, but a website, and so I will click on the website here, and the type would be again a URL, and the manufacturer would be Jira, and the model name would be Jira System 55. Good. And so you can, of course, add additional owners, additional manufacturers here. There are buttons here. You can see, perhaps hopefully it's big enough. Maybe I can increase a little bit the size. So you can add here additional manufacturers and owners through these buttons. Instrument type, that I would say at the higher level would be simply a thermostat. The variable measured is temperature. Now the dates are things like when it was available. So this building was constructed around 2016. The type is not exactly also here what we have, but I can perhaps choose available. This is when the thermostat was made available in the building. Now size is a field that we don't have, but I suspect that I could give the size of the instrument about 7x7 centimeters. The geographical location also is again something that we don't have, but spatial limits I don't know, but I could describe Hanover as where the instrument is. And then resource type. I think what we had for resource type. So this could be, so this is also something we don't have. So a description could be, for instance, what we have. There's the resources, in particular an instrument. And for category here, you can select, you can select a few types. And again, it doesn't quite fit yet. I think it would be great to have maybe directly instrument, but I would say the closest is anyway a physical object. So I would suggest today to use physical object. Format, yeah, I'm not quite sure what to do with format. Yeah, this is a field that B2Inst has, because I think, to my understanding, it's a general field that they have. So, and version classic 0.1, and that could be a contact email for this record. So not for the instrument owner or manufacturer, but for the record, and that could be something like myself. Yes, and I think that's it, although I'm a little bit surprised now. Yes, so here you have to hide details and show details. So here you have also the possibility to capture related and alternate identifiers. So for the related identifier, if you look this up, you can find there is something like a catalog, that the company has a catalog. You can take on the URL here. That will be again a URL, and I think they have this here. And the relation perhaps could be something like is documented by. And also here you can take on multiple. You can other related identifiers like a paper describing, and an alternative. An example could be my daughter is upset. I've been talking too long in the microphone. So an alternate identifier could be, for instance, the EAN, which they publish on the website. And again, here it's up to you then to know whether there is a serial identifier of the instrument that you want to capture, and so on. And in addition here, you can also add other resources like an image, perhaps of the sensor, and a location map or something like that of the platform and image. Good. So I think that was it from my side.